So 9.5b starts with factoring, and I want to rewrite each part as a cube. So use your square card or your cube card. We're going to replace 64 with 4 to the third. X is already to the third, minus 1 is its own perfect cube. All right, the first parenthesis just takes away the cubes. 4x minus 1. Then with a cube pattern, I need 3 spots for the second parenthesis. Square the first to get the first. Square the last to get the last. Multiply them together to get the middle. If the minus is right away, the rest are plus. All right, there's no GCF. It's not a special pattern, so I just need 2 parentheses. Now, if we're building 6x squared, let's start with 3x and 2x and 12. Now, I don't know if anyone had watched my alternate way to factor. Let me kind of use this to kind of give you the opportunity to see this again. What we do is make a square, putting this in the top and this at the end. If you multiply them together, 72x squared, and list the factors, 172 we use these factors to look for which ones subtract to get 1. 8x and 9x, because I still need the x squared. Then we look for the GCF. If I look at the GCF this way, is 3x. GCF this way, 4. GCF this way, 2x. GCF this way, 3. So 3x gets the 4, 2x gets the 3. To get a negative 1, I need the 9 to be negative. Negative 9 plus 8. And that's my factored form. Number 3 does not have a GCF. This is a special pattern, the difference of 2 squares. So break apart 25x squared into squares. 5x times 5x, 36y squared, 6y, 6y, 1's a plus, 1's a minus. So these are all of the different patterns that you've got to know in order to factor. Now let's start with the fraction part. Your least common denominator is built with factors. 2x plus 1 is already factored. There's nothing more I can do with it. 4x squared, though, this is the difference of 2 squares. So we're using our squares, 2x and 2x, plus 1, minus 1. All right, so we want common factors. I just pick everything that's in the first denominator, which is 2x plus 1. When we jump over to the next denominator, we already have one of its factors. We just need the other factor. So you're building your least common denominator with all of the factors in the original denominators. All right. Everything is factored in number 8. What you have to understand, this plus connects the x and the 4 together. This is all one factor. This 4 here is different from this 4 because this 4 is connected to the x and this is just a plain 4. You need each one of the factors. Now, typically, I would put the 4 in the front. I would like this way better, but if you have it written like this, I would take that too. All right, so first I have to factor the denominator. This is the difference of two squares, x plus 1, x minus 1. So I build my least common denominator. I'm going to write each factor from my first denominator. When I come over here, we don't have an x yet. I'm just going to stick that in the front because I like that single piece in the front. But we already have the x plus 1, so I don't need another one. These are all the factors that I need in my least common denominator. Okay, the most important thing in order to simplify is to check to see what is it that you're doing with the functions. Here I'm adding. Here I'm adding. Here I'm multiplying. So we have different rules for add and multiply. When you add, you need a common denominator. Only when you add or subtract do you need a common denominator. All right, so if I'm adding and I have a common denominator, that I'm just going to put my answer over this common denominator, and I just go across 7 plus x. All right, so one thing that's super important, this plus connects the 7 and the x together. This is all one factor. This minus connects the x minus the 2. That's all one factor. There's nothing that we can cancel from top to bottom because 7 plus x is not the same as x minus 2. This is my final answer. Number 11, the first thing we need to do is get a common denominator using common factors. So if I factor the bottom, factors of 2 that subtract to get 1, plus 2, oops, forgot my x, minus 1. So this denominator has a factor of x plus 2 and a factor of x minus 1. In this denominator, I already have an x plus 2. What else do I need? So it's a common denominator, x minus 1. If you need to multiply the bottom by x minus 1, you need to multiply the top by x minus 1. We now have a common denominator made up of our two common factors. So I'm going to put everything over my common denominator of x plus 2, x minus 1, x plus 1 times x minus 1. We just distribute, which is just x plus x minus 1. Then I can combine like terms. For my final answer. Number 12. I am multiplying, so I do not need a common denominator. Factor the top, factor the bottom. A plus b is already factored. A minus b, already factored. A squared minus b squared, difference of two squares. A plus b, a minus b. GCF in the bottom of 2. Factor out the 2. We're left with a plus b. A plus b, this one cancels this one. A minus b cancels this a minus b. Anything from the top can cancel anything from the bottom. Nothing else can cancel, so I'm left with a plus b over 2. This is a minus, so I need a common denominator made up of common factors. So I need to factor x and x, factors of 30 that subtract to get 1, minus 6, plus 5. If you get stuck factoring, a lot of times this other denominator will contain a common factor. So that means this side should have an x plus 5. That might give you a hint. Now, what do I need here so that it matches this denominator? X minus 6. If I have to multiply the bottom, I have to multiply the top. I now have a common denominator of x minus 6 times x plus 5. So I can bring my numerators down. X minus 1 times x minus 6. Now be careful. We're going to distribute this negative 1. So this turns into negative 1 times x is minus x. Negative 1 times 6 is plus 6. So we distribute this through. Now I combine my common like terms. X minus x cancels. So I'm just left with 6 in my numerator because these cancel out over the common denominator of x minus 6, x plus 5. What do you notice about the next problem? It's a divide. With division, we do not need common factors, but we need to change it to a multiply problem. Multiply by the reciprocal. So first of all, when I bring this one down, I'm going to factor the GCF out of the numerator. If I divide both my numbers by 2, I get 2a minus 3. I'm going to change to multiply by the reciprocal. Well, I'm going to put 3 squared, which is 9, on the top. I'm going to put 3 minus 2a squared on the bottom. All right, now we are multiplying, so we just need to cancel the common factors. 9 cancels 9, top to bottom, common factor. Now, notice this is almost the same. With subtraction, though, if the order is different, I need to include a negative somewhere in the problem. So this can cancel out one of these. So I'm left with this negative 2 on the top over 3 minus 2a in the bottom. Because remember, squared means there's 2 of them, right? That's what squared means. So this one would cancel this one, so we're still left with one of them in the bottom. I just need this negative because the order is switched with subtraction. Final answer. All right. Now, so this x is factored. There's nothing more I can do with it. X squared just means x times x. So this means that all of them need 2 plain x's. So that means I need to multiply this by an x, top and bottom. This is all connected. This does not have a plain x. So I need to multiply this one by x squared, top and bottom. Now, they also all need a plain x plus 3. So this needs an x plus 3, top and bottom. And this needs x plus 3, top and bottom. So my common denominator is x squared times x plus 3. So I have x times 4, which is 4x times this x plus 3. Let me move this over a little. All right. Minus, what am I left with here? 2 times, x plus 3 over my common denominator of x squared times, now don't be canceling this, we need this for our common denominator, plus 4x squared over x squared times x plus 3. I need all of these pieces in my common denominator. So I'm going to distribute this, 4x squared plus 12x. I'm going to distribute this. This is a negative 2, negative 2x minus 6. And then I'm going to combine like terms. 4x and 4x, 8x squared, 12x minus 2 minus 6. All right, this one isn't a multiply, add, subtract, nothing. It's just a basic, plain old simplify. Factor the top, factor the bottom. Factors of 16 that add to get 8, plus 4, plus 4. Difference of squares. Notice the 16 is first, so whatever multiplies to make 16 has to go first. Then a squared plus a minus a. Now it doesn't matter when you're subtracting or when you're adding. The order doesn't matter. If you have a plus 4 or 4 plus a, it's still the same thing. Common factors, simplify. That's your final answer. All right, 17 is a little more complicated. This is one factor. This is a different factor. We have to factor the final denominator. X and x. Factors of 6 that subtract to get 5, plus 6 minus 1. Now notice, these two each have a plus 6, but this one needs a plus 6. So I'm going to multiply top and bottom to get x plus 6. Now these two both contain x minus 1. This one in the middle still needs x minus 1. So my common denominator is x minus 1, x plus 6. Now I'm going to distribute. X plus 2 times x plus 6, we need to distribute. X times everything, then 2 times everything, minus, distribute the 2, negative 2x plus 2, because negative 2 times negative 1, minus 14, because that didn't need anything extra. So I just put all this on the top, kept my common denominator on the bottom, combine like terms. This is my only x squared, 6x plus 2x, 8x. Ooh, I still have that minus 2x. So that's 6x. Then 12 plus 2 minus 14 is just 0. But we always need to make sure our answer is in simplest form. This I can factor out an x, GCF of x. So x plus 6 cancels. My best final answer is x over x minus 1. All right, I'm going to make some room here. So if you need to pause the video. All right, so this side is already factored. We just need to factor this side. X plus 3, x minus 3. Now, I have an x plus 3 and I have an x minus 3. See how this side has a plane x? This side needs a plane x, so I multiply top and bottom so they have the same. This side is missing x plus 3, so I multiply top and bottom by x plus 3. X times x, x squared, plus, distribute the 3, 3x plus 9, all over the common denominator of x, x plus 3, x minus 3. Last 3. So this is a subtraction problem, so we need a common denominator. This is just over 1. So that means I can multiply anything I want. Since this side has an x plus 3, I'm just going to multiply top and bottom by x plus 3. If I distribute the 4, 4x plus 12 minus 5 all over my common denominator of x plus 3. Combine like terms, 12 minus 5 is 7 over my common denominator of x plus 3. This is a division problem, so I need to multiply by the reciprocal. I'm going to save a little space and just factor as I go. This numerator, difference of 2 squares, 2x, 2x, plus 5 minus 5. The bottom is also the difference of 2 squares, x plus 4, x minus 4. Multiply by the reciprocal. So when I look at the bottom, GCF is 2x. I'm multiplying by the reciprocal, so I'm just switching these two. If I divide everything by 2x, x plus 4, GCF of this numerator is 6, but I'm putting it in the bottom, 2x plus 5. Now, anything from the numerators can cancel anything from the denominator. X plus 4 cancels x plus 4. 2x plus 5 cancels 2x plus 5. 6 is 2 times 3, so the 2's cancel. I'm left with this x and 2x minus 5 over this 3 times x minus 4. Last problem. All right. So this has a 3, so they all need a 3. So I'm going to multiply everything by 3. This has an x, but this has an x squared. So I need to have, everything needs to have an x squared. Because if I multiply x times x, I now have x squared. Here, though, I need to multiply by x squared and x squared. So my common denominator is 3x squared. X squared times 1 is just x squared. Let's just do this all in one step. Plus 3 times 3x is 9x minus 4 times 3, 12. And there's nothing that we can do to simplify. Final answer.